In today's lesson, we are going to be talking about statistics still, okay? Topic 5, two-way tables, okay? So two-way tables can be represented as two-way frequency tables. Consider the following survey. There are 149 elementary students who are asked to choose whether they prefer math or English, and the data is broken down. So 42 males prefer math, 47 males prefer English, 35 males prefer math, 35 females prefer math, 25 females prefer English. You can take this data, okay, and make what we call a contingency table. And that's what we're going to talk about next. Contingency table helps you find other information about the data, okay? So we're going to make a contingency table here, all right? Here's my contingency table. If you'll notice, I put in my information, 42 males prefer math, 47 males prefer English, 35 females prefer math, 25 females prefer English. This area right here, it has a green circle around it, is called your joint frequencies, okay? Joint frequencies are where the preferences are joined together. So you need to go ahead and fill in that contingency table with the numbers, okay? They give you 4 numbers. You do have to find the totals on your own. Sometimes they'll give you the totals and you have to find other numbers. We'll talk about that in a minute, okay? But your joint frequencies are those in the middle where your topics are going to join together, okay? The other area is called your marginal, and you can think of it as they're in the margins, okay? So marginal frequencies are where your totals are going to be. So I added for males 42 plus 47 and got 89. 35 plus 25 for females and got 60 females. So 89 males, 60 females were surveyed. Okay. For my total, there were 77 who liked math, 72 who liked English, for a total of 149 students who were surveyed. Okay. Next thing we're going to talk about is our relative frequencies table. So here, this is a shot of the table that we just did, our contingency table. A relative frequencies table is going to have decimals, okay? In order to create a relative frequencies table, you're going to take each joint frequency in the contingency table right here and divide it by the total and round to 2 decimal places. So first, we're going to take our math and divide it by our total. It gives me 0.28. Okay, so that number goes right here for math. Males and math, it's 0.28. Okay, then I'm going to do 47 divided by 149 and get 0.32. 35 for females who like math and 149 and get 0.23. And females who like English, there's 29 out of 149, and that's 0.17. Okay. Now, in order to get my marginal, these are my joint relative frequencies right here, okay, because they're in my joint area. So then I need to get my marginal relative frequencies. Well, all I do, like I did before, I'm just going to add them together. 0.28 and 0.32 is 0.60. 0.23 and 0.17 is 0.40. Okay, then I'm going to add my math and English together. Okay, and if you'll notice, I get 1. You should either get 1 or 0.99, okay, or 1.01, something really close to 1. Okay, that's what you should get each time you do a relative frequency table. Okay, so this is how you make a relative frequency table. Okay, then you can take these relative frequencies and turn them in percentages. So 28% of the students that were surveyed are males that like math. 32% of the students that were surveyed are males that like English. 23% of the students surveyed are females that like math. That's what this table tells us. Okay, so we're going to do a couple problems. A survey of high school students asked if they play video games. The following frequency table was created based on their response. So what we need to do is we need to go ahead and total everything up. So 69 plus 60 is 129. 65 and 85 is 150. So that's 279 total. All right, 69 and 65 is 154. I'm sorry, 134. 60 and 85 is 145. These two should also give you 279. Okay, so those are just my totals for my contingency table. It says compute the joint and marginal relative frequencies. Okay, so that means I'm going to need to divide each of these in the joint area by 279. And you can divide each of the marginals by 279, or you can just add up, which is what I usually do. So 69 divided by 279 is 0.25. 60 divided by 279 is 0.22. Okay, that means this margin is 0.47. Females, 65 divided by 279 is 0.23. And females who don't like to play video games, 85 divided by 275 is 0.30. Okay, again, you can add those up. That's 0.53. And if you add 0.47, 0.53, that gives you 1, which is your whole. Okay? All right, next we're going to add 0.25 and 0.23 and 0.22. So you can do 134 divided by 279 and you get 0.48, or just add up what you got for your joint relative frequencies. Okay, so that's part A. Part B, how many female students do not play video games? So female students, here they are, and I'm looking for do not play video games. Now they're asking how many, okay? Well, the how many number is 85. You're looking at where they join together. 85, right there. What percent of students interviewed, so that's out of this total, okay, were females who do not play video games? Well, we know the total is 279. We know there are 85 females who do not play video games. Okay, so we found this before. It's 0.3. And remember, if you're changing something to a percent, move the decimal 2 spaces to the right, no matter what. So 30% of the students interviewed were females who do not play video games. Okay? All right, so this one, sometimes you'll end up with a problem that you are going to have to fill in all the blanks. Okay, so they give us stuff. Number one, they give us their 1,700 total students. So we're going to write that in. All right, then they tell us 59 of the 491 freshmen are left-handed. Well, we know there's 491 freshmen. 59 of them are left-handed. If I want to find out how many are right-handed, I'm just going to subtract 491 and 59, and I get 432. Next, it says out of 382 sophomores, okay, 289 of them are right-handed. So now I need to find my left-handed sophomores. So I'm going to subtract 382 and 289 and get 93. Next, it says there are 433 students who are juniors. 120 of them are left-handed. So I'm going to find out how many are right-handed by subtracting 433 and 120. And that's 313. Okay, the next one's kind of tricky. All they tell us is there are 307 right-handed seniors. So seniors, 307. But I have enough information that I can figure out the rest of what I need. Okay, so what I'm going to do first, since I have all of my right-handed numbers, I'm going to add them all together. 432, 289, 313, and 307. And I'm going to get 1,341. So I know those, and I can do that. Okay? Also, I know since I have 1341 and I have the total 1700, I can find out how many left-handed students there are. So I can take 1700 and subtract 1341, and there are 359 left-handed students. From there, I can find the other senior information. I can just take my totals here and subtract out what I got. So 359, if I take out the 120 for juniors, the 93 for sophomores, and the 59 for freshmen, I get 87 seniors that are left-handed. Okay? Next, you can either subtract these three numbers from 1700, or you can add 307 and 87 together, which that is probably easier. So 307 and 87 is 394. So now I've got all of my information. Okay? And I need all of my information because I need to know if they ask me about a relative frequency that I can find that information. Okay. What is the joint relative frequency for a right-handed freshman? So out of all the students, there are 1,700. I am looking for right-handed freshmen. There are 432 of them. Okay, so I'm going to take 432 and divide it by 1,700, and that joint relative frequency is 0.25. Okay, so that is my joint relative frequency, right-handed freshman, right here, divided by the total number surveyed. All right, part C says, what does the relative frequency 491 divided by 17 represent? Well, 491 is in the margin. Okay, 491 is freshmen. Okay, so this is the probability or the relative frequency of freshmen surveyed. Okay, that's how many freshmen were surveyed. Next, it says circle the smallest marginal frequency. So let's look in the margin. And really what I'm looking for is the smallest number. Okay, I have 491, 382, 433, and 394. I also have 1341 and 359. So the smallest number is 359, okay, for left-handed. So we're going to find our relative frequency by dividing that by 1,700. So 359 divided by 1,700 is our marginal relative frequency of 0.21. Okay? So, again, if you are finding your relative frequencies, you're just dividing. Okay? All right, conditional relative frequencies. These are given conditions. It's not out of the total. They give you the condition. Okay? So, example 1, recall the student's class subject preference data. Principal says that males in the interview have a stronger preference for math than females. So why might he say that males have a stronger preference for math than females? Because 42 out of the 77 males like math, where 35 out of the 77 females like math. So 42 out of 77 is 0.55. And 35 out of the 77 is 0.45. Okay, so when you are doing conditional relative frequencies, there is going to be a condition that is given. It's not going to be out of the total or out of all the students surveyed. Okay, so this is a high school talking about video games. We have males and females who either play or don't play video games. They've already given us our margins and joint frequencies, okay? So question number 1, what is the percent of students who do not play video games? This is our condition. Students who do not play video games. So let's find do not play video games. There are 145 of them. And the next thing says are female. All right, so let's find female. 85. Okay? So we are going to do, instead of 85 divided by 279, we are doing a condition where it says percentage of students who do not play video games are female. All right, so we're going to do 85 divided by 145, and that is 59%. Okay, remember, you get 0.59. Move your decimal 2 spaces to the right. All right, number 2. Given that a student is female. So, let me erase what I did before. All right, given that a student is female, there's 150 of them. What is the probability the student does not play video games? Female, not. So 85 divided by 150. Now, when it says probability, sometimes it wants you to leave it as a fraction. So 85 divided by 150. And then math enter is 17 out of 30. So it could be left that way. Or 85 out of 150 is 0.55. That is your relative frequency. Okay? Again, you are given a condition. Okay? Of the students who are male, that's our condition. So let me find how many males there are. Okay? There are 129. Probability the student plays video games. All right? And 69 out of the 129 play video games. And again, you can either leave it as 0.53, okay, or simplify it, 23 over 43. A lot of it depends on what the answer choice is. It may be in a decimal form or it may be in fraction form. Okay, number 4, the percent of students who play games, there's our condition, are male. So, students who play games, let's find them. All right, here's play games. All right, here's students who play games. And here's male. So they tell us to set that they want it as a decimal or as a percent. So I get 0.51 when I put that in my calculator. And remember, I'm going to move it 2 decimals to the right, so that is 51%. Okay? Again, conditions. And remember, when you're trying to change something to a relative frequency or a percentage, you're going to divide. Okay? Let's do this next problem. So we're going to go ahead and fill in our totals first. 36 and 55 is 101. 134 and 67 is 201. Okay. 136 and 134 is 170. 55 and 67 is 122. So this is going to be okay, let me go back to this. This is not 101. This is 91. So 292 is my total. Okay, so questions. So it has questions, and then it says, ask which frequency it is. All right, part A, what percent of patients? Well, all of them are patients. So of patients, that's 292, were recommended for braces. So out of all the patients, 91 were recommended for braces. This is a marginal relative frequency, okay, because we're using the margin and the total. All right, so our marginal relative frequency, is for recommended for braces. So it's 201, not 91, Miss Lott. So that's 201 out of 292. So 69% of the patients were recommended for braces. Okay? What percent of patients without wisdom teeth? There's a condition here. It's not of patients, it's of patients without wisdom teeth. So here are patients without wisdom teeth. Okay? There is 122 of them. Patients without wisdom teeth. Okay? And then it says not recommended. Okay. No wisdom teeth, not recommended for braces. So that's 55 out of 122. So 55 out of 122 is 45%. Okay, this is a conditional relative frequency. Okay, what percent of those with wisdom teeth? Okay, so again, there's another condition. With wisdom teeth is 170. Were recommended to receive braces. So with wisdom teeth, recommended for braces is 134. Okay, so 134 divided by 170, that is 79%. Okay, this is also a conditional relative frequency because it is given a condition. Okay, does there seem to be a relationship between the presence of wisdom teeth and recommendation for braces? Well, yes, there does. Okay, if they have wisdom teeth, 79% of them are recommended for braces. Okay, so that's kind of the difference between a relative frequency and a condition. The relative frequencies is out of the total, out of all of them, out of all the patients. Okay, the conditional has a condition set for it. Okay, that is going to be the end of our two-way tables. You have some extra practice that you can work on, and again, the answers to those will be in the back.